grade 8 mathematicians. I hope that you are all doing very, very well. I wanted to make this video so that we can focus on Pythagoras, but not just any Pythagoras, like not the beginning, not how to do it. This is a video for if you already know the Pythagorean theorem and you want to engage with some easy, harder, and challenging questions. So if that is for you and you are preparing for an exam or a test, then these are those types of questions that you would get in an exam or in a test. All right, so let's deal with that. So Pythagoras, you know, very, very important, has to happen in a right-angled triangle. All right. I always say to my students as well, it's the two sides touching the 90 degrees. So those two are your two legs that you're going to add together squared, and then it gives you equal to the hypotenuse squared. All right, so just if you get confused, just stick with, don't go with the way where you say if you've got the hypotenuse and the legs, say hypotenuse minus, just stick to your adding. We are adding the two sides touching the 90 degrees, whether you have them or not. And that gives you the hypotenuse squared. Okay, all right, so let's look at a very easy question. A right-angled triangle has one leg of 6 centimeters and another leg of 8 centimeters. So let's go draw our triangle, right-angled triangle. And we're going to label that the one side is 6 centimeters and the other one is 8. And then it says calculate the length of the hypotenuse. So I'm going to mark that as x. And then I've got this side as 6 centimeters and over here 8 centimeters. So now you don't have to go and label your triangle. And if it is labeled, you don't have to start with AB squared plus BC squared is equal to AC squared, that whole thing. You can just work with the data that you've got in front of you. So you can say the two sides touching the 90 degrees added together squared will give you the hypotenuse squared. Okay, easy as that. I feel some students get so confused with the AB squared plus the BC squared, and sometimes it's A squared plus B squared is equal to C squared. That is just the way that your triangle has been labeled, and that is just, for me, an introductory lesson as to which sides do you add and, you know, what is the protocol? Do you square them? Which one is it equal to? So if you know all of that, just jump in and use your values already given to you. Okay, very important. You have to always write Pythagoras. Okay, and I always say if you can't spell Pythagoras, just write Pyth. All right. So now another thing that I want to focus on is the Pythagorean triplets. So if you ever want to go and have a look, or you want to go and Google the Pythagorean triplets, those are two squared numbers that is added together that will give you a perfectly square rootable number. So what that means is that the value here for x is going to be a integer. No, not even an integer. It's going to be a positive, you can say a positive integer, or it will be an won't be zero, so let's call it will be a natural number. It's no decimals involved, and those are the ones that we call the Pythagorean triplets, and I'm sure that you've come across some of them. One of them that's very, very popular that the teachers use is where you've got a 3 centimeter, a 4 centimeters, so 3, 4, and then your longest side, just note that your longest side must always be your biggest number, which is 5. The hypotenuse would then be 5. So if you see a triangle like this given, and the teacher perhaps does this, and she says, what is x? Now, immediately you can say, that is a Pythagorean triplet. It's a 3, 4, 5. So x would be 3 centimeters because of Pythagoras. So you don't even have to show any calculation. If you know the triplet, you can just write it down. So this one that is over here in front of you is also a Pythagorean triplet. And those students who know me by now, I always drill this into them: 6, 8, 10. Okay, but let me just go and show you how we're going to work that out. So 36 plus 84. Oh my word, 8 squared is 64. Mrs. Townsend, is equal to x squared. So 100 is equal to x squared. And just for future reference, grade 8s, we will always have to, when we square root our answer, so let's say I wanted to go and square root that to get rid of the 2, you also have to square root your answer on the right hand side. So x, just for future, can be a positive or a negative 5. Because if you've, again, hello, wake up, 10. So if you've got a positive 10 squared, that will give you 100. But think of this as well. If you've got a negative 10 squared, wouldn't that also give you 100? Because a negative raised to an even number, if you think of your exponent rules, also results in being a positive 100. So now for your Pythagorean questions or your Pythagoras questions, you don't have to add the plus minus, because what are we actually working out here? We are working out a distance. All right, so the distance is always positive. So that's why we will always look at the positive answer of the square root of that number. Okay, and that gives you that x is equal to 10 centimeters. So this is another triplet that I want you to try and remember. So if you've got one leg that's 6 and another one that's 8, then you know that your hypotenuse would be 10. And can you still remember the first one? 3, 4, 5. Okay, there we go. So let's move on to question 2 when you are ready. It says, in a right angle triangle, the hypotenuse is 13 centimeters and one of the legs is 5 centimeters. So we've got one of the legs is 5 centimeters and the hypotenuse is 13 centimeters. Now this is also a Pythagorean triplet. Obviously, if you're going to go Google it, there is many, and there's lots and lots of them. So you can't remember all of them, but we try and remember the ones that we use the most. So 3, 4, 5, 6, 8, 10. So for this one, we want to know the length of the other leg. So I always say to my kids, stick to your basic addition. So it's that one squared plus x squared. Then the maths will follow itself. X squared plus 5 squared, or your algebra, is equal to 13 squared. Okay, so do you see whether you've got that leg? That is the one, the two touching the 90 degrees. Those are the ones that you're going to add together. So if you want to go simplified, you can, or if you want to throw it over and subtract it already, you also can do that. Remember to write Pythagoras every time. Now we're going to pick up that 25, throw it over to the other side. He's going to become minus 25, or basically we want x squared alone, and then we subtract 25 on both sides. Hey, so 169 minus 25 gives me 144. And then the square root of both of those gives you that x is 12. And then just always double check to see if your answer was right. Just make sure that your hypotenuse stays the biggest number. So if you got over here x is 15, then you know, I've done something wrong, because one of the legs can't be longer than the hypotenuse. Question 3. Now this is more visual. You need to see the picture, how it relates to Pythagoras, and then that you also must know that you must use Pythagoras in this. Okay, so the more you do, the more you're going to get used to where to use what. So a ladder leans against a wall, and the foot of the ladder is 10 meters away from the wall. So if I had to draw a wall, there's the wall, and the ladder is leaning against the wall. So let me just do it like this so we can see that that is the ladder. But then they're also talking about the foot of the ladder, which means over here, the foot of the ladder is 10 meters away from the wall. So that distance over there is the distance between the ladder, the foot of the ladder, and the wall. All right. Then they say, and the ladder reaches a height of 24 meters. Okay, so the ladder reaches this top height. So that is the height it reaches as 24 meters. And now you can just see, did you draw it correctly? It says calculate the length of the ladder. So can you see? Yes, that's the hypotenuse. That is your ladder in your picture. Okay, then we're going to start the two sides touching the 90 degrees. Where would be the 90 degrees? Over there. So the two sides is 10 and 24, gives you the hypotenuse squared. And thank you, Mr. Pythagoras. So now you can just go punch that into your calculator. 10 squared plus 24 squared is 676. For those grade 8s who don't use calculators yet, your teacher should use simplified numbers. So it would be like that the two added together gives you 25, or, an easy number that you can recognize what the square root of that is. Okay, I like to write my x first, so I'm just going to swap it around. So x is the square root of 676. So the answer you get, 676, and that answer you get is 26 meters. So the ladder is 26 meters long. Second last one, question 4, which is a little bit more challenging, not at all that much. Okay, so a rectangular TV screen. So let's go draw a rectangular TV screen. They say has a width of 32 centimeters. Okay, so a width of 32 centimeters would be on the top here. So if you think you've calculated, or if you've put it in the wrong side, the rest of the questions would guide you as to whether you did that or not. Okay, and it has a diagonal of 40 centimeters. So we know that any rectangle has all angles of a rectangle are 90 degrees. And then they say calculate the height of the screen. So can you see, if you perhaps wrote the 32 over here, centimeters, and they say calculate the height, then you would have said, oh, but okay, so, it doesn't matter. You could have used that x or just calculated that x, but if you want to make your picture seem more correct, you can have just swapped it around. All right, and there we've got our Pythagoras. So let's work it out. If you are scared, it's the two sides. Go and highlight the two sides touching the 90 degrees. So it's those added together squared gives you the hypotenuse squared. And thank you, Mr. Pythagoras. So now to make it a little bit quicker and easy, in your calculator, you can punch in, because as you bring that 32 squared over, you have to subtract it on that side. So in your calculator, you can punch in 40 squared minus 32 squared, gives you that x squared is 576. And only now we're going to square root 576. Because it's a distance, it's always the positive, which is 24 centimeters. And again, let's go have a look. Does it make sense that this leg is 24? If your hypotenuse is 40, remember your hypotenuse must always be your longest, your biggest number. And yes, it does make sense. All right, and then the last question, which is not the most challenging, but it's more challenging. All right, Jane is standing on a playground. She starts by walking 16 steps west from the swings towards the jungle gym. When she reaches the jungle gym, she turns north and walks a further 12 steps towards the jumping castle. Calculate the distance between the jumping castle and the swings. So when you read this, there's two things that I notice I need to do. I need to make sure that I remember where is north, south, east, west. North, south, east, west. My mommy knows best. And I don't know the other ways of remembering that. And then we need to start drawing what this Jane is doing. So she's walking 16 steps west. So let's start Jane off over here. And west is to the left. That's a bit skew. And then she gets over there. And they said it's 16 steps. So I'm going to put a 16 over there. She starts by walking 16 steps west from the swings to the jungle gym. So from the swings, so if this is the playground, this is where the swings would be, and she walks towards the jungle gym. Okay, then when she reaches the jungle gym, she turns north, so basically upwards, and she walks a further 12 steps towards the jumping castle. So now she turns north, and then she reaches the jumping castle. And that was 12 steps away. Okay. Calculate the distance between the jumping castle, which is over here, and the swings. So can you see they are looking for that distance created over there? And because she was walking west and then immediately north, can you see that that creates a 90-degree angle over there? So what can we use to work out the distance? And obviously, you know, we're busy with Pythagoras, so that is what we're going to use. So the two sides touching the 90 degrees is 12 and 16. So we're going to say 12 squared plus 16 squared, and you can go and put in a little x there to say that is what I'm calculating. And thank you, Mr. Pythagoras. And 12 squared and 16 squared gives you 400. And if I square root both sides, then I'm left with x is 20 steps away. Square root of 400 is 20. And because we were walking with steps, it will be 20 steps from the jumping castle to the swings. Okay, people, I really hope that you found some, that this benefited you from what you could see, and that you could have an insight as to what type of questions you might get in the exam or in a cycle test or a class test. And I really thank you for watching my videos, and there will be more to come this year. I am really looking forward to making lots of videos to help the grade 8s, 9s, 10s and 11s. Mostly the GET phase, which is the senior phase, because I just love enjoying, I just love teaching those grades. All right, but lots and lots of love, people, and I will see you next time. Have a wonderful day. Cheers, bye.